There, 1828 Higley Road. I think this is it on the right. This building. This looks like 1828 to you?
Yeah, it says 1828.
Maybe April. Alright, so here we are. Looks like vehicle parts. COVID came like maybe, a few weeks afterwards. And then we've got people all kind of scattered across the US in Florida, Wisconsin. Used to have one in Maine, he now lives here. Was taking them and we could do this remote. We figured out with interns.
Hardware
development and intern projects and stuff like that remote. So we've got some very unique things that are in development there that are completely different in the industry. It's kind of unheard of as to the way we're doing this. Wow, this place is big. Huge. Massive place. Ani comes from A123. His specific focus is actually on battery cells and development of battery cell systems. And then Archit is doing packs, but he's more on the computational side of things, the science side.
I did.
We set up, this is the one we just did the YouTube video on.
Yeah.
Cleaned it up a little bit where we did the test, was it 8 minutes 55 seconds
The first
for the demo? And then we just did 8 minutes 30 the other day, which now it's like give or take a little bit. 8:30 versus 8:55 to the average person is probably not going to matter much.
Right.
Whereas when you're going from an hour to 8 minutes, that's actually a really big change.
Okay.
The market, including Tesla.
Right. So what's going in? What's that tube that's going into the battery pack?
So that's actually a coolant system that's running through there currently. So there's a high dielectric fluid that's in there. We talked about. Remember before we talked about submersing the cells in a dielectric fluid. And what we're doing there. So that's what that's doing. There's a pump, there's actually a heater on that system, and then it's running it through the pack while the system is set up and running. So, we got viruses.
Alright, so they're going to run the test for us right now. We're going to see how fast it charges. Is it from 0 to 100? Is that what you're going to do?
Yeah, so it'd be 0 to 100.
Should I turn this on? Wait.
There we go.
Alright. So this has a little bit of a head start.
So the one on the right is industry standard?
Yep, one on the right is the industry standard, one on the left is the ATLIS Tech that's
Okay.
here.
I think we are done.
So how do you, I see the actual battery module on the screen is showing the fill. Yeah, the one on the left is going, your battery's going up fairly rapidly.
You guys adjust these?
Yeah.
Okay.
So another 1% at 42 seconds.
Alright.
Turn it off at the pump?
No.
Yeah, it's pretty impressive. So right now, yeah, you're like a third full.
Yep.
Yeah. Ionic resistance?
So the thing is, a cell has two kinds of resistances. One is ionic and one is ohmic resistance. So when you change the temperature of the cells, it changes the ionic resistance of the cell, and it drops it down. So changing the ionic resistance actually increases the amount of current it can accept and the amount of charge we can put in it. And that is the core that we use for charging these.
So how do you change the ionic resistance?
By changing the temperature of the cell.
Temperature, that's it. So you just have to, raise it, lower it? It has to be at the same temperature all the time?
No, so the idea is there's a few papers out there that corroborate that when you raise the temperature of the cell, it drops the ionic resistance, and our experiences with previous tech also does that. And it also, when you're charging, you do that, and when you're discharging, you cool it down.
Yes.
So
yes.
that brings back so that preserves the life of the cell when you bring it back down to the room temperature.
All right, so you want to keep it at a higher than normal temperature when charging, though?
Exactly,
That's
yeah.
what you're going to do? Okay.
So a lot of companies are doing that, but we are doing it more actively as to speak, and we are also working with a lot of charge profiles and everything to be able to accomplish quick charge.
Yeah, let's see how it's doing right now. Almost half full. Yeah, that's great.
Architecture contributes to it, right? It's not just because more the industry standard cells are more aligned towards high energy densities.
Okay.
This is a slightly different approach. We're designing it that.
Yeah, so the core of what you're doing is you're expecting the user to rapid charge this thing as fast as they can every single time, because
So
they're not going to be...
everything that goes in the cell, like your coatings, your electrolytes, your material choices, all of those are aligned towards quickly charging the cell.
Okay, so that's your customer, and then other electric car companies are more designed for residential users, consumers who are driving locally and not doing long distance driving for the most part.
So Mark has actually set the specifications for us to be able to design the cell from the ground up.
Yes.
And the battery pack from the ground up. So we are, I think, one of the only few companies in the world who's doing
Correct.
cells, modules, packs, everything from zero. So everything from the cell to the pack is designed in a way to manage thermals, to manage electrical connections, to manage quick charging, discharging. So that's why we are in a unique position.
Yeah, I agree. Yeah, how's it doing? Like, that's just over 8 minutes. Almost done. Almost done.
Well, sure. Yeah, 92%.
It's going to be close.
So right now it's trying to balance all the cells.
Yeah, it slows it down at the end.
So it will just jump as soon as all the cells will balance themselves.
Yes.
So if there's one cell
You
that's
switch
still
to, I
being
think,
charged,
constant voltage. Does it do that?
Yeah, it's pulling them all so they're even.
It's just going to pull all the cells.
So it will switch to constant voltage and decay the current when it was topping up the cell.
Well, I come in just under 9 minutes there.
So this one is at
Yeah,
20% on
20%.
95.
Now with this demonstration, once it hits 100%, it's not going to cool the pack. It is just for demonstration purposes. But
It'll keep cooling, but yeah, this system will keep running while it cools the fluid.
oh, it will. Okay, so this is going to be very, very similar to what you envision in the trucks.
Yeah.
Because if it doesn't cool it down, it'd just be sitting there destroying the life of the product.
Correct. Never want it to go above a certain voltage, even when charging.
Okay.
So even if like you're trying to pump a lot of current into it or make other changes, then you never want it to sort of like go above a certain potential across that cell. So we're always trying to make sure that we don't do that.
All right. And that's part of the reason why it slows down.
Yep.
At the end. Like.
Yeah. So what it's doing right now is it's just balancing between the different cells. Yep.
So they have that understanding.
Right. So actually, I just mentioned, I just wanted to tell everybody here on the video that my Tesla is locked in with a maximum of 90 kilowatt charge rate. So it reduces the time, or actually it increases the time of my charges because of that for the life of the pack. Tesla has that on every car, and I'm sure other manufacturers do that as well. But you all are throttling back charge rates, or are you for?
Not planning on it from a customer experience standpoint.
Okay.
So internally, the system will manage the cycle life and what that experience looks like, but we're trying to minimize that potential impact for the life of that particular pack or that vehicle.
Right.
In our case, the pack will last a certain amount of time, the vehicle will last a certain amount of time, and we're looking at that overall sort of lifespan or what that end of life looks like, and we're trying to work towards that consistent experience from day one till the end day, whatever that happens to be.
All right. So we're talking about the range.
Yeah, so if you look at Porsche, their EPA range is lower than, say, a Model S.
Mm-hmm.
But they actually, unlike the Model S, they outperform their EPA range in real world driving conditions.
All right.
So ATLIS's approach is not necessarily to focus on EPA ratings, but focus on our customer driving experience. So we're talking about big, heavy vehicles that drive on highways, they drive off-road, they are intended to tow and haul heavy loads. So we're designing for that use case in that scenario. We're not designing for best case 150-pound person sitting in the driver's seat in a sort of fixed, stop and go city highway driving scenario that the EPA follows. We're much more concerned with what's the practical application and how do we design around that to give the best possible customer experience.
Okay, because EPA has there's no factor in there for towing anything on the EPA or putting in a big heavy load in there and driving around with it.
No, and when you look at like the way the drivetrain and everything is designed, much less the battery technology, it's designed for that best case scenario for the EPA driving cycle, not necessarily for high duty cycles, high power outputs at highway speeds. That's where their efficiency curve kind of drops off, become very inefficient. That's why a Tesla, when you hook up a trailer to it like you're experiencing, that range drops drastically.
At least by half, I'd say. Sometimes more if I'm trying to drive at the same speeds on the highway. Forget about it.
0.0015
on a train, on these giant trains.
On basically a train on rails basically has a rolling resistance of like 0.0015 or something like that.
Because of all the momentum, I suppose?
No, it's just the contact area that you have.
Oh, I see.
So small.
I see.
So cars roll better than trains?
So no, cars are what's the rolling resistance in the car? It's
not the rolling resistance. This is static resistance. Static coefficient of friction.
Yeah.
And on a normal tarmac, it can be as high as 1.1 if you are like if the tarmac is good, but typically it's around 0.8 to 0.9.
You have to think like the top of the rail is curved, right, and you have a flat, basically, train wheel, and that contact surface area is so small. That's why people can tow train cars, right?
What happened with the Ford? The Ford ad,
towing like a massive, load or something with a big rope, right? And they're pulling this thing because they can. So when Ford did the video, and we don't want to knock Ford necessarily, but when they did the video, it's a little misleading because it's on rail cars. So the rolling resistance and the static friction is so low, it's actually very easy to tow that. That's why they had such a small tow strap there.
Right. Yeah, I get you. Because it's just going to go no problem at all. Yeah, that makes sense.
Right. So a real world scenario would be put it on tires with rubber, with friction on pavement, right, and see what that looks like.
Exactly.
Pick up a chain and tow a big boulder or something.
That's got some.
That's a gimmick.
That's some resistance, though, right?
Like not tow a bunch of train cars or whatever else. That's just it's a waste of time and it's misleading.
Right, I got you.
Public.
It's not anything that would ever be done on a practical use of the car, and it doesn't necessarily show any real brute strength, I guess.
No.
Yeah. So yeah.
Doesn't do much for you other than marketing.
All right, this was not a record pace, but it's still pretty good. Under 11 minutes. So this one's still at 27 and going, not even close. 38%, something like that. So you might as well stop it now, right?
If you're from
We're
Michigan,
talking about suspensions here.
Yeah, if you're from Michigan, like I am, you remember potholes and rough roads and stuff because every year, right, the snow melts and the road gets rough.
I'm from Pennsylvania.
Yeah, driving a truck on those roads can be very painful. And then washboard roads and stuff like that. I mean, it's teeth chattering vibrations and stuff. So you don't need a bunch of ground clearance to do that. You just need a great suspension system, good shocks, dampeners, something that changes variably as well. But in our particular case, what we're really trying to focus on is dialing that in. So, like I was saying before, is that as the wheel moves up and down, we get as minimal camber change as we possibly can, but still maintain ride performance and handling and things like that. So you do want some, but you don't want a ton of it. You also want to minimize the toe of the tire, especially in the front and in our case the rear too, because it's a steer axle in both cases.
Really?
Okay.
So as that tire comes down, it's going to pull and toe in, right? Or it's going to pull and toe in at the top. So as that tire moves, it's moving in an arch, it's changing camber, and it's towing in and out as it sort of moves through that suspension path. So we're doing a number of things in the finished product to minimize that motion or to be able to dynamically adjust that motion.
Dynamically adjust the motion.
Yeah, so so right now we have a prototype drive-by-wire steering system in there. We've got another system in development today, but then the production solution that the guys are working on is individual control per wheel.
Nice.
So the right and left wheel are not tied together.
Oh man.
So we can change those dynamic characteristics based on your driving conditions or trailer load or payload in the back and things like that to adjust for that. We can also, in theory, you could do a remote alignment of the vehicle without ever taking it in.
Wow. Yeah, that's
Or
impressive.
dynamically adjust that alignment as it's driving down the road.
Okay, so all this is tuned and optimized for work use of the vehicles too. All of this.
So
right?
you have to balance unloaded versus loaded.
All right.
So a heavy duty truck today, or technically it's a medium duty truck,
Right.
or a light duty truck, they ride really well when they're loaded.
Mm-hmm.
They don't necessarily ride very well when they're unloaded.
Correct.
Because that suspension and everything is so stiff.
Yeah, it'll throw you all over the road.
Yeah, it doesn't want to move. So, and they're getting better. I mean, there's nice balances and stuff that are there, but we're trying to balance that unloaded versus loaded scenario and make improvements across the board. In kind of at launch, you sort of aim for that middle of the road like everyone does, but then through software updates, and we can continuously adjust that.
All right, so if you got sensors on every wheel and every wheel is doing something different, potentially, you can have the computers optimize everything while you're driving down the road, right?
Yeah, so in day one, you design for standard use cases and everything else in terms of configuration. And then as you collect data and as we make improvements, we push updates out that then allows us to make adjustments and move things around. But we have to do that without adding tens of thousands of dollars worth of cost
True.
to the vehicle.
So
if we're
that's
aiming
another
for-
balance.
Yeah, if we're aiming for a $45,000 truck.
Yeah, you've got a great price point.
Right, we can't add $20,000 worth of sensors and technology into it. It doesn't work that way. So the steering system has to cost less than $500.
And costs keep
With
coming
more
down, so
components.
you'll be able to do it, hopefully, right? Yeah.
What's that?
You'll be able to do it. Costs keep coming down as we go, right?
Well, cost comes down, but it's also your approach. So, don't aim for the best solutions. Don't use things that are super expensive, but also work through problems as you're going through it. So a best example would be we could buy a $5,000 sensor that would give us the most accurate measurement that you can imagine, but it doesn't work in real world use cases: dust, water, rain, ingress, temperature conditions. Think it's more like a lab sensor.
Right.
We're looking for something that's automotive grade, and then the real sort of technology advancement comes in the software and how we apply those measurements to algorithms and logic systems to give you an accurate sort of motion of the wheel or detection of position of the wheel. They're not your daily commuter. I've never put anything in the back of my truck. That's actually a relatively small percentage of the market.
Okay.
It's not as we
talking about truck
perceptively,
usage, uses
anecdotally
of trucks.
think that it's high, but it's not. You see a lot of these guys driving back and forth to work in their pickup truck because they're a dual purpose vehicle. It's a commuter vehicle, but it's also the thing that tows the boats to the lake on the weekend. It's the thing that tows the camper to the campground on the weekend or on vacation. Maybe they do side jobs or they're the weekend warriors that are like building something in their house and they use it for that. They have a trailer for it. That's actually a good chunk of that market.
Right.
So anecdotally or perceptively, we think now they just drive to and from work. You could say that about me, but my
You're
truck
one of
has
them,
been put through quite a bit of use.
Right.
I've used it very specifically for what it's for. It's just it's not every day that you do that.
Yep.
So roughly, 51% of the market is actually work-specific vehicles. Of the other 49%, a good chunk of that is people that use that truck for its purpose. They just don't use it every single day, 90% of the time. So they might use it anywhere between 20% and 5%, and that's when you drive value for that customer. Don't focus on the 80% use case. That's not market value. Real value is in the 20% or 5% that's left, because that's when you have something, it becomes useful. It becomes something that you can actually apply to whatever it is you're specifically trying to do.
Okay.
And that's where you go from, God, this thing is a piece of shit, to I love this thing. Right?
Yep.
It's that thing where you don't get frustrated anymore. You're like, hey, I got my job done, I got whatever it is I wanted to do, and then also I can go to work on Monday.
Yeah, and you're also developing cabin chassis, so you're going to be able to do custom work bodies on here, and it's going to be capable of doing all this and do it well. And that's all that is being engineered into these products.
Yeah, so we're very intentionally focusing on those use cases, because if you look at the market, people that buy pickup trucks, the SUV market is moving to pickup trucks, right? It's the new family vehicle, but pickup trucks serve a purpose beyond just being a family vehicle. It's the idea of what they can do. We want to focus on the work market very specifically. Yes, consumer market's open to us, but focus on that work market. One, it's the largest chunk of the pie, but two, it's also an opportunity for us to go beyond just vehicles. So ATLIS is not just a truck manufacturer. We're an ecosystem company. We're a technology company.
Okay.
And we're really focused on not just the vehicles, but the energy team, battery technology, charging systems, that ecosystem that's out there. Then we're focused on the platform and what we can do there that's in adjacent markets that we're not chasing today. So think upfitter markets.
Okay.
And then, of course, when we get to the vehicles, we've now built that infrastructure out with the first two pillars. And once we get to the vehicle side of things, then it's pickup trucks, it's bigger pickup trucks, then it's fans and various different vehicles after that we have planned.
Okay, and let me also mention, I know we talked about this a little bit earlier, when you talk about the best-selling vehicles in the United States, you're talking about pickup trucks, you're talking about a Ford, Chevy, GMC, those products, but those people who are not thinking or not in the know, I guess, about all these sales are thinking, well, that's just those regular trucks that go down the road. They don't think about the work body trucks, and those are all included in those numbers. Is that right?
All of that's included in those numbers.
And your guys are you are focusing on that. That's a market you're going to get into. Like if we talk about Tesla, they're not focusing on that market at all with the Cybertruck.
I think, yeah, Tesla's focused on lifestyle. Rivian's focused on lifestyle.
Right.
ATLIS is really focused on work and that ecosystem that's there. The energy side, the platform side is our foray into various different segments within that environment. The pickup truck is our brand sort of launch into that. That's how we get in the front door with these organizations and build brand confidence.
Yes.
Then future vehicles that we have planned sort of are still planned within that ecosystem. So it's not just trucks, but it's very work-centric, work-specific applications.
Okay.
So if you own a farm or you're in the agriculture business, we want to be eventually sort of that one-stop shop for your equipment and vehicle needs. And make it very easy to own those, very easy to maintain those things. Not just sell vehicles, but work on the fleet management, the maintenance management, of that entire sort of ecosystem, simplify that for you. So you can focus on your core business, which is whatever it is, farming, construction, mining, whatever that happens to be. We'll try to provide the solutions that make that possible.
All right, and then one thing to bring this all back around is that you are a company that's, of course, all electric.
Yes.
So you're basing everything on electric architecture, optimizing everything for full electric, whereas if you look at traditional manufacturers such as Ford and Chevy, I don't necessarily think that they're doing that.
They're trying to build on platforms that exist, or they are making a switch, but it's a much more expensive, much more difficult switch for them. Dealership models are not built out for this. Their sales models aren't built out for it. Their vehicle architectures are not built out for this. It's also catalog engineering. So it's a lot of
parts bin technology.
Pull it together, assemble it, and distribute it. Huda is very familiar with that environment.
Okay.
Working at past startups in this particular space, as well as Chrysler, right?
Yeah. So I was working stationed out at Chrysler, and my past experience is also Faraday Future and Byton. So it was also based on like, okay, what is in the market, and we just kind of were putting everything together. And when you think about as a startup, that doesn't work because you really have to look at your architecture. You really have to develop everything in-house in order for you to meet, your mile range, in order for you to meet your customer needs. So that at ATLIS, and like as Mark explained, that's what we are developing everything in-house to meet that customer needs, meet the mile range that can take you 500 miles.
Yeah, and you're not constrained by past technologies.
Correct, or what's off the shelf.
Yes, because in most, if you're looking at legacy manufacturers, their stuff is off the shelf, is all ICE-based.
Yes.
So, yeah.
Correct.
Their body control modules, the entire vehicle architecture is basically, the only thing different is the drivetrain The rest of it is built off the existing architecture and systems that they've done for the past 20, 30 years easily.
Yeah.
Whereas we're looking at this thing from the ground up.
Yeah, I think you have a tremendous amount of advantages in doing that, in my opinion. So I think you're doing a great job.
Right. And there's a slight delay between when the throttle opens and when the engine receives enough air to generate enough power to break things loose. And then once you do that, there's no finite control in that.
Correct.
So
Yep.
it's this very difficult thing where it's like
Talking about traction
Yeah,
control.
when you talk about traction control, you're talking about like cutting the throttle, right, and closing that valve, basically, the throttle body that's in there, or applying the brakes to a specific wheel to reduce the amount of actual power that's put down to that specific wheel, or transfer it to another one, or use differentials and all sorts of complexities, clutch systems and stuff like that. I mean, there's like an endless degree of things. But a lot of that is, in fact, all of it is almost this concept of like, let go, release, let go, release, let go, release.
Until you develop some friction or you lock on something, you
It's
can
more or
use
less
it.
you put too much power in a location, so grab a hold of that location, put that power somewhere else,
Okay.
and then move it back and forth. I mean, all of those systems are kind of working on more or less on that
I see.
principle.
I see.
With electric, it's more of how much power can I put down until it releases,
Yes.
and then back off from that and do that in milliseconds.
Okay. Yeah. So with what I see with an ICE vehicle, you've got all that power. You've got to do something with it.
Yeah,
That's what you're saying, right?
It's very difficult to do precision power delivery to a specific location, versus like coming back and doing, okay, well, how much power can I put down at this specific wheel versus this wheel versus this wheel versus this wheel, and dialing that in to a very, very, very precise number from an acceleration standpoint.
Yep.
So
electric is a huge benefit over that.
yeah, the electric is like, what would be the equivalent? I think of it like, trying to come up with a great example, but it's more or less just like the difference between operating software systems in like a computer game where you can control something and it very precisely moves, and that system, versus like going back to old school toys and stuff where you're just playing with like, you know, wood pieces or something that's just like you bang stuff around or just move stuff around. It's like the toys from the 1920s versus toys today, which is all digital.
Yeah, total paradigm shift.
Yeah.
If I say, when I talk to people and I try to explain this, especially people that have never driven electric before, it is a paradigm shift, like you say. But also, you've got to have a well-designed electric vehicle. Just any electric vehicle. If I take certain older models, like I won't, without saying anything bad, I'll say like, you know, like for instance, the Nissan Leaf never had a complete temperature control system on the battery pack, right? And they had problems with it. It just wasn't designed well because they had to keep costs down for these early models.
And it's all traditional is cost driven. It's finance driven development versus customer driven, technology driven. And we try here not to focus on innovation for the sake of innovation. That's the first time I think I've said Chris's quote without butchering it.
Good job. Nice quote.
We
I like
try
it.
not to focus on innovation for the sake of innovation. It's really trying to solve a problem. So,
problems are opportunities in disguise.
right. So any new technology that you introduce should not introduce new problems that change the previous experience and make it less than you've experienced before. It should always be a step forward or a leap forward. Electric vehicles today, in some aspects, are leaps forward, but then in some aspects, they're leaps backwards
Right.
in terms of that experience. Battery technology, currently in the current implementations as well as the upcoming ones with a lot of startups, is still a leap backwards in customer experience.
A leap backwards because of, I think you and I have talked about this before, like for instance, I'll come out in the cold weather to my car and the battery pack is stone cold, it's almost frozen, and then because of that I have almost zero regenerative braking.
Yeah, I mean lithium freezes below, what, 0 degrees C?
Yeah.
So when lithium, like when that electrolyte begins to freeze at lower temperatures, that completely negatively affects performance of that vehicle.
Yes.
So all of those things do matter. And when you think about internal combustion engine vehicles have had over 100 years of innovation. I remember in the 80s and 90s when you couldn't start your car in the middle of winter. That is not a problem you have today.
Right.
Right? Even a diesel truck, you have to, in really cold climates, there's a different fuel, right? Because there's an additive that's put in there for that. But having my diesel truck from 2013, I remember going through, you know, the northern states and those extreme cold environments and never having a problem with it starting. It always gets up and it always runs. And that performance is consistent when I'm doing that.
Right.
Whereas
Because they've
an
had so
electric
many
vehicle
years.
today,
Yeah.
when it's hot or when it's cold, there's a compromise that has to be had there. And that in my mind is not acceptable. That's a step backwards or a leap backwards. So while it's cool to have gimmicks and games and all these fancy things inside the car, if the basic experience is not satisfactory, then it's a negative sort of, it's a negative for that particular product. Think about the first iPhone, right?
Mm-hmm.
The first iPhone had apps and all these toys and stuff, but what did Steve Jobs show in the presentation? He showed how cool and easy it was to make a phone call. Right? Like, he showed the basics of what it's supposed to do and what added features they made that basic experience better with. And then on top of that, you had everything else that's there.
Mm-hmm.
With electric vehicles, today it feels like sometimes we're focusing on the apps and the other stuff, but we forgot the basics.
Right.
So we need to get back to the basics.
Yeah, and with the work truck, you need that thing going to work right away the minute you jump into it.
Yeah, I remember when I was a kid, my dad would get up at 2 o'clock in the morning because somebody was in a ditch or somebody was in an accident or something like that. He'd have to go out, get in his truck, his tow truck, right, and drive to that site. There was no scenario where, you know, that thing wouldn't start, it couldn't work, or couldn't get out there and do the job. And sometimes those are long distances that he'd have to go to get that in the middle of northern Michigan.
Super cold temperatures.
Super
I'm sure.
cold temperatures, really crappy weather, conditions you don't want to be stuck in.
Mm-hmm.
So when I think about the experience I have today, would I do that in a Tesla? Probably not.
Yeah.
But, you know, ATLIS building this work truck, that's a use case that we have to focus on. We can't make that compromise.
Mm-hmm.
Even though where I'm from, the winters aren't that bad anymore.
In Arizona, yeah, Mesa, Arizona, where we are, right?
Yeah, so, but in particular, it doesn't really matter in those use cases. They still exist, and we still have to design for that. It still has to work in that scenario. And it can't, it's either going to be that good or it's going to be better. It can't be less. Show some of the detailed stuff
We
there.
won't show,
Obviously, you can
yeah.
see most of that stuff there.
Yeah.
So that's the XP platform.
Secret
We're
stuff.
showing the videos and everything over there. It's got most of the systems installed right now. On the motor systems, gearbox systems, integration with the battery pack, and actually what all that stuff is they're developing the vehicle dynamics controllers, the logic systems, pedal integration, brake integration and stuff for all the brake-by-wire stuff, as well as, because it's 4 individual motors, right, you have to have, each motor travels at a different speed. There's various different characteristics and stuff that are kind of built into that. So we actually, you know, we're a startup, we're on a budget, so we raise the system up, we bring it up off the floor, and that allows the team to actually just run the system constantly, over and over again as they do that. And then we drop it back down, and we do some rolling tests and a couple of other things, and then it's sort of a back and forth operation.
And this is a skateboard design. That's what they call it, right?
This is so this is our skateboard design. It's the concept and prototype. It's a buck, basically. So
Yep.
It's not finished product. This is something where we take things off, we put new things on, right? It's sort of butchered, so to speak, from, remember the original concept we showed online when we did that? That was a concept. Now it's, things are implemented into that, right?
Refined.
Things are wired through it. It's not going to be pretty. It's not. It's very much so a development vehicle.
Yeah.
So the systems that they're specifically focused on right now is all the prototype systems for the drive control units and everything that's involved there. What's different between the industry, even Tesla, and what these guys are doing is how we're integrating the cooling systems, the battery management systems, and everything into basically a structural module.
The cooling
that's built
system is going to
into
be
it.
structural.
So the cooling system will be structural. So whether the battery packs are technically immersed in fluid, but it's not really a true immersion because they're flowing and things are moving through there.
They're completely immersed?
Yeah. So and then the second thing
That's dramatically different because I think, if I understand right, Tesla just uses tubes,
they use tubes, and then there are others. Faraday's, I think, doing submersive cooling. Nikola did a version of submersive cooling in their packs provided by Romeo Power.
Okay.
It's not abnormal in the industry. What is completely different, though, is what these guys are doing from a structural integration of the cooling system. So imagine eliminating the heat exchangers and stuff that are up front in the vehicle, because our requirement is that the battery pack is a self-contained unit. It's power management, DC to DC systems, DC to AC systems, cooling systems, all of that is basically a module that's loaded in. And it's structural in how it's actually constructed, but you don't have like a separate radiator system for cooling on the outside of the pack. All of that is actually integrated into the structure of the vehicle.
So wait, it's integrated into the structure. Are you able to give us some details on that? How do I,
not yet.
Not yet.
That's
I have a hard time envisioning that.
Yeah, and that's the problem, is the more detail we go into, the more we give away.
Yeah.
But just imagine like combining all of those systems together into less parts, less components.
Yeah, less parts is good.
In terms of what it is.
Yeah,
So
of course.
when you look at, say, existing EVs that are either in development or on the market today, there's hundreds of feet of coolant lines running through.
They're like one of these geothermal heating systems for your house, basically.
Yeah. We're eliminating those more or less completely within the vehicle. So we don't want cooling systems and valving systems and all this stuff running all over the place. Each one of those is a failure point. Each one of those is a wear point.
True.
Each one of those is an extra component that we have to buy and engineer and install. For every component, that's a failure mode that's there. So if you have 100 components, it's 100 times 99 times, it's 100.
Nothing lasts forever.
Factorial,
yeah, every part will break at some point. It's
right.
only a matter
So the FMEA for that is a nightmare.
Yeah. So if we can eliminate all of that headache and complexity, it's more work up front. It's a much harder problem to solve, but it's actually a much simpler implementation.
Correct.
So, when people ask how do we get to market faster, well, you start by taking 100 components and throwing them away, and starting with, can I do it with 2 or 3?
That's also why you're going to have a big advantage here as long as you do it right. Again, going back to that well-designed type of electric vehicle, because you're not using the part spin technology we talked about that are designed for ICE vehicles, which has ridiculous amounts of parts. I know that EVs themselves already have much lower amounts of parts, but you're going to take that a step further, it sounds like.
Correct. So if you look over here, this team over here is really, it's drive modules, vehicle dynamic systems, steering systems over there, brake-by-wire. Like, that's the team that works in this particular corner over here. If you turn around here to the other side of the building, back there, sort of along the back wall and everything, we've got the fabrication team. So they're working on, we've talked about box truck integration. So that platform can actually take that cargo box that's being painted and finished back there, and we can actually install that on the back.
Right.
And then we have a mock cab for a box truck over there in the corner. So we can actually demonstrate this modular concept of what the platform is. So that platform, there's no mechanical linkage outside of the body mount fasteners for each of these different pieces. Everything is drive-by-wire.
All right.
So what is it? It takes us, 15 minutes to unplug and pull the top off?
That's it.
And most of that's just walking around unscrewing a couple of things and moving, and mechanical gantry systems to move it. So basically what we can do is we can take that box system, or way over there in the corner is the off-road buck that we've shown off a few times now in a few different videos. All of that stuff is plug and play on that platform.
All right.
So rather than develop a system that's claimed skateboard, that's really just a cutaway of the basic vehicle, that's a true drive-by-wire modular skateboard system.
Yeah, that makes sense.
The front and rear drive axles are identical, including the suspension systems, the subframe systems, all of that stuff.
Because they're all these wheels are steering? Is that right?
This particular model, we took steering out of the rear, but yes, they're all steering in the final production model.
All right.
That's there. On the other end is the front, actually, of the platform, and that has the prototype for the drive-by-wire steering system.
Okay.
So back here in the corner, we've got fabrication, model building, and things like that. Coming up in January and February, we'll start the construction of the XT prototype. So that's what everybody's sort of anticipating that comes in. So right now the teams are finishing up some of the design work that's there. We're working with suppliers to get some of those parts made. So a lot of that stuff's going to start coming in January and February. And we'll start showing off those builds. All of that will actually happen along the sort of the back there. Over there in the corner, or on that side, that's the energy group, where the battery labs, cell labs, and stuff are going up. So teams are working with partners to get the quotes in, to get stuff kicked off there. We've actually kicked off an arrangement with a university to start work on the final chemistry that's going in the cells. So we're hoping to finalize that by, what, February?
Are you going to be producing your own cells ultimately? Is that what
Yes.
this is?
Yes.
All right.
Yep.
So everything's in-house then?
Yeah, so everything's in-house. And then back here, actually, this group that's sort of huddled right there, that group is actually focused on body control systems. So we're developing, basically we call them Omega modules, that are basically body control modules, but it's a single design that can be used in different systems. So today, in a vehicle, you have you have a body control logic system, and then you have separate HVAC modules and systems, separate chips, separate software, separate everything. Doors are different, headlights, taillights are different, trailer controls, interior lights are different, or they're controlled by the body control module. There could be anywhere between 20 and 30 separate body control systems in a vehicle. We're developing one modular system that can be applied in all of those locations. So we can basically dev once, validate it, put it through its paces, beat that thing up, and then it could be installed anywhere in the vehicle, and that reduces the amount of complexity, time, engineering effort, resources that we need to apply to that particular problem. And then those resources can focus on what that plugs into. So if it's simple, well, relatively simple things like windows or door locks or lighting systems, whether it's interior or exterior lights, if it's seat controls, heating and cooling systems, again, all of that is modular and integrated into it. Nothing's shared between the platform. It's just power and communication rails that come up.
Very nice. Okay.
So we're trying to eliminate the 2 miles of wire that's in a vehicle and create basically communication buses and power buses that run along the chassis actually of the platform. And then when you drop a vehicle body on top, you just plug into it.
Okay, very good. I also want to mention here, right before we finish with this little segment, that normally there would be folks at all these workstations, but because we're here on a weekend.
Yeah, it's
right?
Saturday.
Yeah.
No one's here.
Yeah.
I think they're at, I don't know how many there are actually. The team's at 51 today.
51
we were
people.
5 in January. No, well, 5 at January 1st, and then we were 15. So Hanchett is the only one here, but Hanchett remembers working out of my house for like a couple months.
Oh, yeah?
So we were 15 in there, and then when we moved here, we maintained, remember I talked about we brought in a bunch of interns over the summer. We actually doubled the size of the company just with interns. And what's different about ATLIS versus other companies is our interns, which some of them are still here, they do mission critical projects. We don't give them tasks like, hey, go like cycle this resistor and do this thing. Our interns were designing charging systems, inlet handle systems for the charging station. Some of them were doing battery pack systems, control systems, wireless communication for the charging station. Power electronics, yeah.
When you say the charging station, are you talking about high-speed chargers?
The AAC system that's in development today, so we'll have a 1.5 megawatt system versus Tesla's 250. We do know they're working on a mega charger.
Those are for heavy trucks, though, right?
Yep. So,
okay.
But our system is consumer driven. So, hang on 1 second, let me grab something here. Just a 3D printed prototype, but rather than be focused on commercial applications, we're focused on something along these lines. This was the first prototype,
wide.
but this is it's no bigger than a CCS handle, really. Maybe a little bit
This
larger.
is big.
Yeah, but this is 1.5 megawatts. So you're talking about a difference of like 350 kilowatts to 1.5 megawatts. So almost, what, 4 times?
Yeah, and I'm
5
only getting
times?
90, like I said earlier, on my
Right.
car right now. I can't get more than 90.
It's like comparing car parts to locomotive parts.
Right. So, but we're really trying to focus on, the rule is my grandmother has to use it.
That's
So it's not something where it's an industrial application. It has to be one of those situations where somebody that can fill up their gas today at a gas station with a normal pump should be able to use this system. But we need to bump that power way up to be able to accomplish this. So this is the first sort of 3D printed concept of that. And actually, there's science and stuff that went into this. We have a new system that's in development today that's built on this concept, using the same approach and stuff, just different connector geometry and stuff, just based on the power requirements and stuff. It's kind of like finalizing it.
Right, just like an industry standard? Is
No.
No.
So we're not going with CCS or Tesla standard.
So you're developing your own industry standard for this type of an application?
Right. So we're actually developing the inlet, that mechanism, the cable systems, and all of that stuff is being developed in-house because you can't buy it.
Right.
If you were to use industry standard contacts and connectors, like if you use the ones that are similar to what they use in CCS or Tesla, you'd have 6-8 of those.
They don't have the highway isn't wide enough, right?
Yeah, it's not enough contact area to meet that requirement.
Yeah.
So we're talking 1600 volts, 1000 amps. So it's actually 1.6 megawatts when you think about it that way. But we only need 1.5 roughly for the pack, the largest pack that we have, plus some for heating and cooling systems. So yeah, so again, it's for ATLIS, we're building battery tech, but we realize you have to solve the charging side of it.
Yeah, so you're planning your own complete network of chargers.
Correct. Yeah, so the business is built in energy, platform, and vehicles. The energy group is really focused on, one, building the technology to make this possible, but number two, we're also looking at the infrastructure side of it. We don't want to just be a company that sort of deploys charging stations at Walmarts and stuff like that. We're looking at the complete picture of that infrastructure. So charging depots and things like that of that nature.
They're going to be drive-through, right?
Drive-through, always drive-through.
Because I've had such a pain in towing.
No pull and park scenarios. Maybe for CCS, just because, why not? But even then, we're looking at pull-through scenarios because there are vehicles coming up that use CCS that are going to be towing and hauling.
Yes.
So we might as well make that a much easier implementation for them. But I look at it this way: is imagine someone else driving up in a competitor's vehicle or another vehicle using CCS, and they're sitting there for an hour and a half. And in that time period, 6 ATLIS trucks are going to go through.
Yeah. With massive trailers and stuff and heavy weight.
Right. So, but to do that, we have to develop this tech. So over the summer, our interns work on critical path projects like that. They get real world experience, not tedious tasks. And that's how I came up through school. And that's the expectation that we have here is no one just comes in and does a simple thing. Everyone does a lot of stuff.
Right.
We put it in the, we're looking for a CFO currently. And in the middle of that, I jokingly said in the middle of it, one of the skill sets is that they have to be able to unclog a toilet. And that is actually in the job description that Tamika posted up there, because it's true. I clean restrooms. These guys clean the restrooms. We all do.
If someone made a mess in there, they know, right? You're gonna find out who it was. You go clean your own mess.
But the reason for that is very simple: is that there is no such thing as that's not my job. So Hanchett came on board for structures, right? And you're doing structures today, but he's also doing heating, cooling systems, fluid dynamic systems. He's doing, I mean, you did wiring and brake-by-wire systems when you started as well. So the team members that come on board, they have to be able to tackle problems that are uncomfortable for them. And
that's how you grow, right?
That's how you grow.
Innovate.
And when we talk about intern programs and stuff like that, where we started the conversation, is that those team members come on board, they're inexperienced, they've never done this stuff before, they have to be able to do this. And if you want to, and this is just my personal opinion, if you want to be a successful engineer in your career, you have to learn every aspect of that. You cannot specialize. Don't be specialized in one little area and say, well, someone else is going to do the CAD, someone else is going to do this. You have to understand that whole system, because let's say things don't work out or you want to change jobs or careers or move, you now have a set of skill sets that you can apply in any industry, any application. So that's what we try to teach our interns. And we've hired a few, and now 4 of them, I think now, are now full-time junior engineers or ATLIS employees. So we kept some on for the fall, but we've got one, he's not even graduated yet, but he's actually working as a junior engineer. We've got another one who has not graduated yet that's in Florida, Actually, he's working as a junior engineer now, as a full-time junior engineer. A lot of that is COVID driven, because
Colorado.
yeah, Colorado, yeah, Kishore,
Yeah.
right?
Yes.
Yeah.
And he'll be coming on full time in the summer.
Yep. So we've got a lot of these guys that are sort of slated to be full-time, or some that we've just brought on board. Some of our mechanical engineers, or one of our mechanical engineering interns, he does product design. He did the mirror design, actually, the mechanisms for the mirror designs. He's doing body structures for our digital mirror system.
Digital mirror system.
Yeah, so it's all camera based.
Okay, so you're not going to have any outside mirrors.
No.
'Cause especially on those medium duty trucks, you see them. There's giant mirrors out. They got a big trailer. You don't need that.
Yeah,
you don't need it all.
This is coming from a guy that loves trailering mirrors. I don't understand why you buy a truck that doesn't have them.
They stick out so wide. Yeah.
Right. But they're the most useful, like, sort of system that's on those vehicles, which means that's the bar for a camera system.
All right.
Camera system has to do that plus more.
All right.
So,
Gotcha.
our mechanical intern actually did the electronics, internal stuff, mechanisms, and everything for the motion of those things. He's doing field of view. He's doing basically a lot of the system development for that. And he actually designed the first concept for it. But then at the same time, he's also doing structures, frame structures. He's painting the box truck, like whatever has to be done, he's doing that. And he's eager and he's hungry to be able to do that. And those are the kinds of people that we love here.
Yeah.
It's just the people that are like, what needs to be done? Okay, I'll jump on that and I'll punch that out and get that moving. So from a design aspect, I look at it this way.
But this is for the life cycle of the battery pack.
Yeah,
Because you're putting a tremendous amount of electricity at an incredibly fast rate.
Correct. So we really want to, so everything we do is customer backwards, right? So I look at trucks today last 20 years.
Mm-hmm. Before it goes into the junkyard. Yeah.
Correct. Now we're not looking at junkyard scenarios. We're actually looking at a different business model, which we could talk separately about that.
All right.
When we think about that, I think typically that's a few 100,000 miles of operation. But sort of the world that we're going to is million-mile operation.
Yeah,
vehicles.
I agree. I think that any well-designed electric vehicle should last 1 million miles.
Correct. So when we look at cycle life and use cases, and we talked a little bit about this before, we target 1 million miles consistent experience for that entire 1 million mile life. So that's our target numbers.
All right.
We do have a minimum number that we're willing to accept, but 1 million miles is the target number. So we always push the team to aim above that. So we think 2,000 cycles, 500 miles range, we think 1 million miles. Right? It's a very basic number.
All right.
That number could come down, of course, when you start thinking about if everyone is a towing scenario
Right.
and full load, then that number is obviously going to come down. But that's also a higher, like it's a heavier scenario, or sorry, a much more brutal scenario for that vehicle to undergo.
True. It's the most difficult.
Correct. So
type
other
of
things
driving.
are also going to start wearing out if you're doing that particular thing for every second, every mile of that journey.
Right. So you got to look
throughout
at
that
the whole
vehicle.
thing, not just the batteries. Yeah.
Correct. So that brings us into sort of the subscription circular economy business model, where we're actually thinking about, continuous hardware upgrades for vehicles.
So
over the life of them.
you don't change the vehicle, you just upgrade.
You just upgrade. So you might get a new vehicle in 3, 5, 7 years, or when you sign up for an ATLIS vehicle, and not all details of this are obviously worked out yet, but when you sign up for an ATLIS vehicle, we're looking at never buying another vehicle again.
Your last vehicle.
It's your last vehicle. It's your first vehicle, maybe, and it's your last vehicle you'll ever own until you can't drive anymore.
Okay.
And think about not just continuous software updates, but continuous hardware upgrades and things like that over the life of that vehicle for 20, 30, 40, 50 years. And in 50 years, that vehicle might be completely different.
Okay, true.
But it's this continuously
It's like a
improving
metamorphosis of the
experience.
same vehicle.
Correct. And then when we think about parts that have defects, let's say we'll pick an easy thing, a motor. When that thing breaks down, we bring it back in, we refurb that, but we're not waiting to refurb that to put it back in. We put another one in, keep you on the road, keep you going. That one gets refurbed, it goes back into the maintenance pile, and then for the next person, that one goes back on. But there's a guarantee that that one's going to last a certain amount of time, and when that or any other component fails, it follows that cycle
Okay.
and that process. So when it comes to battery testing, we compare industry standard versus what ATLIS is doing. So if that industry standard application has a certain cycle life that's designed into it, we then compare ATLIS's cycle life under a fast charging and standard discharge scenario. So we don't fast discharge the cell, but we talk about a certain discharge profile that fits within the
Does fast
the test
discharging affect the battery life negatively?
It can, yes. So it can, absolutely. But temperature management, all these other things also play a role in that.
Yes.
So what we do is we actually compare what the industry standard is versus ATLIS to see if there's, do these curves diverge? Do they stay parallel to each other or in line with each other? Is ATLIS doing better? And the data that we've collected so far to date indicates that we don't see a negative change in cycle life of the cells, which means if we say it's 2,000 cycles, what we're aiming for is 2,000 cycles fast charged every single time. And the data we have today supports the fact that we're not seeing a degradation in that cycle life.
Okay, very good.
With what ATLIS is doing. In fact, they're right in line with each other.
Okay, so what were you saying about the cells? Like I got my Tesla has the old Panasonics that were originally designed for laptops in my vehicle.
Yeah, so you're talking about a consumer-driven product, and you're trying to get reliability out of that. And in the consumer market, long-term reliability, cycle life, and things like that are not, they're not necessarily the most important thing in the world. So they have a lifespan, right? Maybe it's a year, 2 years, or something like that. So in order for them to build this market at that particular point, they had to work around that problem. Today, what ATLIS is really focused on is the cell technology designed specific to the application. So not necessarily taking a consumer-based product and then plugging it in here, or even a somewhat improved product and then plugging it in here. We're developing cell technology that's very specifically designed to operate in these conditions, in this environment, not just from a use case scenario either, but from a manufacturing scenario, from a test scenario, from reliability, end of life, what do we do with it? All of that stuff is being taken into account versus taking something, a piece from a catalog, plugging it in, testing it, seeing what the characteristics are, and then basically building your vehicle on top of that. We're actually going, what is the customer requirement, building it at the cell level out to ensure that when we get to the vehicle, it meets those requirements.
All right, so even if someone doesn't understand all these things, they're just going to have an overall better experience.
Yeah. It's consistency in that experience. It's getting something that really truly feels like that leap forward versus a leap backwards.
All right, so what is your cell, your battery cells, the design, and how is that different than what most folks are doing in the market right now?
Right, so most of the market is focused on buying an off-the-shelf solution, maybe with a selected chemistry that's kind of off-the-shelf for them today. But those cells are not designed very specifically for things like thermal management. They're not designed for the application. So ATLIS is designing and developing cells that are very specifically designed for the application. Thermal management is an 80% priority for us. Selecting the right chemistry is a massive priority for us. So the teams are really focused on getting those right for the specific application, but we're also looking to basically eliminate all the middlemen that are involved there as well. We're not looking to buy something from a vendor and they have to make a profit on that. They also then control the supply, they control the cost of that, they control all of that, and then we're competing with the other companies that are on the market. By ATLIS bringing all of this in-house, that means we control that entire sort of supply chain path from the raw materials all the way up till the end product that's in there. So that's how we drive costs down.
Right.
But it's also how we're able to drive innovation at a much faster pace.
Yeah, and
you don't have to convince someone else to build something they've never built before when everyone else is buying something else, so therefore they don't want to build this new thing. We're actually able to do that, and we're able to do it much faster, we're able to do it much cleaner and control that cost.
All right, and you've got a specific product that is different than most automotive manufacturers. You're doing trucks. So you're going to have a different set of goals in mind with what you want. Yeah,
so we're not focused on commuter traffic and day-to-day stuff. We're focused on towing, hauling, heavy-duty use cases. We're focused on more extreme environments. We're focused on sort of what a pickup truck is intended to be used as versus the sort of 80% use case, which is the consumer market. And to be able to do that well, we have to do that from the cell level all the way out.
All right, well, with all the space you've got here, where are the trucks going to be built?
So the trucks themselves will be finished assembled here, and the majority of the components will actually be built here. So with this space that we're in right now, a majority of this will actually be taken up by the energy team with a focus on building battery cells as well as packs. So we're going to manufacture the cells, the packs, the integration of all of that stuff in here. And then of course the platform assembly, motors, gearboxes, all of those different systems, control object systems and everything else will be finished assembled here. Individual components will come from suppliers, but we're not using tier 1 suppliers. So we're not using subcontractor engineering development suppliers to build or to design, develop, and assemble subcomponents. We're actually using a few steps below that in terms of suppliers. So we're getting individual components and parts. We're developing that stuff in-house. We'll bring that in and we'll actually do finished assembly there and then final integration into the platform. The vehicle to start, the body in white will be built by someone else. It'll come in. We'll integrate ATLIS components, interior systems inside that, and then just drop that on top of the platform and drive it out the back.
So there'll be finished products will be rolling out here of Mesa, Arizona then?
Right here in Mesa, Arizona. Yep.
What is it about thing showing it sounds really accurate, like within 1,000 of a...
All right, so this is one iteration of the suspension.
Yeah, so here, like this is, all of this stuff is done through a concept of generative design. So we talk about 10,000 pounds per axle. It's roughly 5,000 pounds per corner. So this is a custom airbag shock design using an existing sort of shock geometry and setup, an existing bag, and then all of this stuff was custom developed for this prototype. And this is all 3D printed. And then these upper and lower control arms are actually designed for the load characteristics and everything, but it's all simulation computer generated, so it's not drawn. We set up all the hard points and everything else, the loads, all those dynamic conditions, and then the computer software actually generates all of these things, and then we 3D print it and assemble it for the prototype. So this thing actually does move up and down. It's functional in that aspect. And then ATLIS designs we actually did the knuckle, the hub assemblies, all that stuff is in-house developed because we can't buy anything that exists today that can handle these loads for an independent suspension system. So
wow.
All of these internal components and everything, we can't
that's
just
beefy.
go out and catalog by it. Yep, the brake systems are Willwood. So this is their particular design for these systems and their caliper for our load rating. But then the hub and everything else that's inside, the knuckle and stuff, all that is ATLIS designed. And then the shock system, that air spring shock system that you see there, that's all ATLIS proprietary tech.
I used to be a CAD drafter, and I don't even know how to calculate these angles and curves.
You can't. That's all computer generated.
That's amazing.
So it's a very cool concept because this stuff right here, if we can find a way to manufacture that on a large scale, that would be a lighter, stronger system than a typical like casted or CNC system that's on the market today. The challenge is like those pieces there can only be made through additive manufacturing processes. Or you could do like a investment or sandcasting process or something like that where you like throw material away when you're done, but it's not very cost effective at high volumes. So this was an exercise we went through as we developed the geometry and everything for that system, air springs, shocks, all of that stuff, printed that off, and then this was a motion simulation system that we were demonstrating actually for a different investor day for that particular setup. But this is a concept. These are technologies that we're actually actively looking for or looking at to implement into the vehicle. So being a startup, we're not constrained by tradition. So we could and may actually eventually build something like this into the system when we launch it.
Okay, we're mask free and just outside of the ATLIS factory. What did you think of that?
Right. That was really cool. I had no idea that they built something that they're going to build a truck that's not disposable like your typical trucks around here.
Yeah.
It's for heavy duty, and you buy it once and you'll keep it forever. If it needs anything maintained, they'll be able to do the maintenance here or maybe in the future somewhere else in a different location. yeah, I really like the concept that they're not just buying parts out of a bin from some other manufacturer, that they're designing their own stuff to their own specifications and with the customer's needs in mind, and it's all long-term thinking, and it's great for the environment.
Yeah, I can't wait to see what the future brings. I guess we're definitely excited after this tour, and anticipating seeing the first ATLIS vehicle roll off the assembly line here, the final assembly line in Mesa, Arizona, in the near future.
Yeah.
Yep.